Hi, okay, welcome to the last video of the unit mass resolution workflow. In this one, we'll be completing the mass calibration. So we'll click here, and I always calibrate on a time series basis. So I'm just going to clear this list. I'm going to start off by hitting the toggle view, because here we can see everything important in the mass cal. I like to make sure that all my files are highlighted. And I'm going to show you a few different ways to do a mass calibration. The first one is if you have a mass cal list. So if you've been doing multiple experiments in a row in a similar setting, or someone in your group has given you a list, you can go load list. In my case, I have one from when I TA'd the class, and I'm going to hit open. And you can either load both the coefficients and the list, or just the list. So I'm going to go for both because this is from the exact same experiment, but if you're inheriting a list that might not have exactly the correct, you might want to go for list, or you can start with one and then clear the list and try again. Just go both. And great, this looks really good because this is from the exact experiment in the spring. So just a few things to point out. This mean residual is an overall accuracy, and right now we're at 20 ppm. And I would say for a unit mass resolution ELF experiment, I would be pretty happy proceeding with analysis if it was less than 100. Here we have our individual fits of the different calibrants we're using and also their individual accuracies. Here we have our peak search range. So if this was this is the area of the blue. If this was much larger, we'd have a larger peak search range. Normally this auto's at 40 and I try and bring it down to 20. And so since we inherited that list, we were down at 20. And this custom shape is what you should be seeing at this stage in the workflow because we use steps 1 and 2 to build the custom shape. If we hadn't done that, we would have been at Gaussian. And yeah, at this bottom view as well, on the right side, you can see accuracy ppm. So 20 to negative 20 axis is pretty good, and that fits with our mean residual of 20. And if we had more than 4 calibrants, we would scroll across to see it. And what I'm actually going to do is I'm going to add another calibrant manually. So to do this, we click on this button here, and we go C7H9 plus, save, and then we added in another one, and we can scroll this way to see it here. Another parameter we can adjust is this D parameter, and this makes the amount of peak that we're like fitting or grabbing to a bit narrower. We go down, so I'll bring it down to 5. And sometimes when you bring it down, if your peak had the calibrant peak that you're fitting to had some really weird shape towards the edges, lowering this D parameter can help bring the residual down. But in this case, it wasn't such a funky shape, so not as much. And yeah, we'll hit this hold list, and this overall looks good. So I'm going to bring the averaging timescale up to 30, which is a good benchmark unless you're looking for something specific and your mass cal might be changing significantly over different chemical changes throughout your experiment. And let's hit calibrate selected files. Bringing it up to 30 makes our actual calibration take less time than if it was an averaging timescale of 2 minutes. We can see in the notebook that it's saving this batch mass calibration to the IF files. This represents the instrument function files. Okay, great, and we're through all 4 of our files, and that didn't take long at all. So our final thing on this is we can hit plot parameters to kind of check out our software overview. And so our file ID just goes up over time because we did 4 different files, so 0, 1, 2, 3. Next thing to bring your attention to is the flag. In this case, the flag is 0 all across the time that we did the mass cal for, which is great. It should always be 0. If it is ever not 0, then it's a bad mass cal and you need to start over. Next up is parameter 1 and parameter 2. These are some of the parameters that we custom built during our previous workflow steps. And in general, I just like to check that the axis ranges in both of these are relatively narrow, and they are, so that's good enough for our case here. And then here we have our ppm, which is a measure of accuracy. And if you look at the different calibrants we used, they can say their accuracy throughout the entire time series. And sometimes they can oscillate up and down. In this case, they didn't. In this case, that last calibrant I added manually was the worst by far. Still not so bad. So I think we did a good job, and we can just close this. And we can also close this window, and we have done the mass cal. It's lit up in green. So that's great. I will also in this video take us over to the batch fit really quickly. So if you navigate to the miscellaneous tab and then fit and integration, you should have these settings, which is screenshotted many times on the slides. And then we just click that button. I'm going to end the video while this runs. Thanks so much for tuning in.